All right, so I'm Michał Wiktorzak, and today I will talk about spatial distribution of the findings in the necropolis, and more actually about how we measured it and how we analyze it. All right, so the excavations in Berenike are supported by quite a few engineering methods for measuring the data and to actually get more from the things we find inside the trenches. We use heavily GIS that allows to make special analysis of findings and create interactive maps that really help in analyzing the patterns inside the trenches and actually see how the objects actually are spaced inside of it. Also, using the photogrammetry and total station measurements, we can measure things that actually allow us to extrapolate, for example, the height and the dimensions of the trenches. During the excavations, there were made around 139 spatial analysis rasters and 25 photogrammetric models that allow us to actually visualize all our work. Also, for the purposes of the supervisors, there was made a project that allows us to actually access the data from the database with a really little knowledge in GIS. The technologies I used, there were quite a few. For the photogrammetry, I used Agesoft Metashape, and to visualize it, I used QGIS because it's open soft. It's like open source, and everybody can access it. For my comfortability, I used ArcGIS Pro and Python to make it more automatic. And thanks to it, I was able to get better results. The area of study was the necropolis, as you can see. And we also took the measurements from the recent years that allow us to actually see how it was in the different areas. Each stage was captured by the photos, and there was made a photogrammetric model that allow us to make orthophotos that were later used in the analysis. This is the result, and as you can see, everything is captured quite well. However, for example, if you can look at the higher right side, there are some points that are representing findings, but it's hard to see how it actually looks, for example, what is what, and to see is there really a pattern. The photogrammetric models are also really useful to capture things that could be destroyed. For example, the bones that came from 157th or 9th trench that later on actually were damaged because of excavations. And thanks to the photogrammetry and using the models, you can still actually get data, for example, how long they were, or actually the shape of them. The analysis was had some idea. There was an idea that was needed for it, because with all the points that are representing the findings, sometimes it's hard to see at what level they are. So we divided each trench like for their levels, and each of them had like the height of 15 centimeters. And the program checked if there are any findings in categories. For example, the categories that we were interested in were pottery, iron and bronze, human bones, and worked wood. And this resulted in an animation, as you can see. It's connected with the kernel density analysis of whole trench, like every level included, and then it goes from down to up to see at which level there were the most findings of each category. Sometimes there weren't any findings in the level. That's why it was needed to actually make less animation, less actually analysis to compute it quite faster, because whole process took about a few hours, and it was needed for efficiency. As you can see, there are some patterns that developed during this analysis, and each trench was a bit different. However, if you look at the human remains, each of the presented trench has the remains at the furthest point from the entrance, and each trench has an entrance from the east side. For example, if you can see here, everything is on the west side, every human remain. But for example, in a trench where there was a looting, and as Kubas mentioned earlier, those remains actually came from a different point, from a different source, for example, from here. You can see that the looting has quite an effect on the state that is presented during an excavations. And these trenches show some pattern. However, it is needed to check other trenches and other areas to check if this pattern really appears in every other situation. In a trench that Emilia was talking about, there was also mentioned that there were big numbers of wood pieces, and as you can see, it's near the entrance, so it heavily shows that there might be a door, and this pattern also repeated in other trenches that were presented. And usually, when we make models and we get the data, we usually, when we use, for example, photogrammetry, we focus on getting an orthophotos for later analysis and getting data. However, it can be also used to answer different questions. For example, there was an idea about the roof and the height of the walls inside in the graves, and this is still an open idea, because we collected the rubble from the biggest proximity of the trench. We actually measured the volume of this rubble to be able to tell at which height could be built wall from this rubble. And we did it using photogrammetry by making a model of this rubble, then getting a volume from using cloud compare, and then thanks to using orthophotos that have really good geolocation, we were able to get the area of this wall. So using really basic math, we can actually get the height of it by just dividing the volume of this pile by the area of this wall. And unfortunately, our results were that there was not enough rubble to be able to build a wall that is higher than 30 centimeters from the state that we were in. So it means that this rubble was eroded, or the graves weren't as high as we could imagine. And this is still an open question, because there is no evidence for the bigger height or some structures that could be over there. And thanks to used methods, we were able to get to these conclusions. And I would say that if we weren't using, for example, GIS or photogrammetry or other measuring techniques, most of our conclusions would be lacking some base, because it allows us to actually come back and check if we actually are going in the right direction. So I would say that this was really helpful, and thanks to it, we can still continue and make some good analysis. Thank you very much.